So we have a temperature of 130 to 140 degrees C. Sometimes it's run as high as 200, and a catalyst of sulfuric acid. So for the first version of this mechanism, I'm just going to abbreviate H2SO4 as just H plus for simplicity. And let's remember, when you have a catalyst, the catalyst must be regenerated at some point because it is something that participates in the reaction, usually to speed up the reaction without being consumed. So we have to get it back at some point. So with that said, let's see how this works. So dehydration, as the name suggests, is to dehydrate, is to remove water. And we can see that is going to come from the OH. In the first step, there's a lone pair of electrons on the oxygen that is attracted to the H+. Then that goes through to essentially a water molecule now, attached at that corner with a full-blown plus charge. The reason why it's a full-blown plus charge is because oxygen has formed a dative covalent bond with a H+. The hydrogen on the adjacent carbon, either this one or this one, it doesn't matter because it's going to lead to the same product, is then removed. Essentially, the electrons from that bond donate into that CC bond, and at the same time this water molecule is kicked out, is released. And so we have the minus H+, so that's the catalyst being given back to us, plus cyclohexene. And that's it. Let's take a look at the same mechanism again, but this time actually showing what the sulfuric acid does. So sulfuric acid is sulfur with two double bonded oxygens, then single OH, and then an O and a H, like that. And then what we have is a delta minus and a delta plus. And then if I use a different color to highlight the movement of electrons. So again, the lone pair is on the oxygen that is attracted to the delta plus hydrogen there. And then the OH bond breaks and the electrons go on to the oxygen. So now that takes us to the same thing as we had above. Hydroxy is protonated to form your leaving group, which is a water. And then the hydrogen sits there. And then we have HSO4-, which now acts as a nucleophile to get back that hydrogen. Minus charge takes off the hydrogen, bond collapses into there to create the double bond, and then the water is released. Okay, so this last step is concerted, so it happens all in one go. So we make the cyclohexene plus the H2SO4, and we can say that's been regenerated, thereby fitting the definition of a catalyst, and then obviously the water molecule as well.